This video is about evaluating functions, and I highly recommend that you watch the meat amorphosis video that I posted on the playlist to just get kind of a look on what a function is. But I'll do a quick recap. This is the main form of a function, y equals f of x or f of x equals y, and a function is an input-output machine. We input x values, or whatever the independent variable is, and then we output y values, or whatever we're calling the dependent variable. This variable that we plug in is called independent because we can pretty much plug in anything we want. It is independent. And we call the output the dependent variable because it definitely depends on what we plug in. Now, we're going to see some functions where we have restrictions on our input. That's called our domain. But as of right now, let's just pretend we can basically plug anything in and we'll get a nice output out. Okay, in this example, we're going to be dealing with two different functions, and I titled the first one f and the second one h. And in our first one, we're going to be using f, as we can see right here, and we're going to plug in -2. So we want to evaluate the function f of x at -2. So our input's -2, we want our output for when we plug in -2. That just means that everywhere there's an x, right here, we want to plug in -2, especially because it's a negative number. We need to make sure that we put it in parentheses and follow our order of operations in order to simplify. We are going to first square -2, then we'll multiply by -3, and then finally we will add 7. So our output's -5. What does that mean? It means that on this parabola, because it's a quadratic equation, on that parabola, when we input a -2, we output or get a y value of -5. That means that the coordinate point -2, -5 is on this parabola. Okay, for our second one, we're looking at the function h, and we are going to plug in a +2. Now, if we look at the function h, we can see that it's a rational function, meaning there's an x in the denominator, and there's actually x showing up twice here. So we're going to plug 2 in both times. So we'll plug it in the numerator, and then we'll plug it in the denominator. And you can see that we will have an issue in the denominator here. So our numerator ends up being -12, and our denominator will end up getting 8 minus 8. So our denominator is 0. And we know that we cannot divide by 0, therefore we say that this has no solution. What that means is that the number -2 is not in the domain of h of x, because if we plug in -2, it gives us a denominator of 0, no good. So we'll write that this one has no solution. If we look back at h of x, though, any other number besides 2 is great. We can plug in anything else besides 2, and it won't give us a 0 in the denominator. So that means we can plug in 0 for our third example. When we plug in 0, we'll get -14 in the numerator. And in the denominator, we'll get -8. We can simplify this. Negative divided by negative is a positive. And 14 and 8 are both divisible by 2, so we'll be left with 7/4. Our last example of evaluating a function will be dealing with a piecewise function, and a piecewise means a function that is literally divided into different pieces. There are no gaps or no overlaps in these functions here. As you can see, g of x is one function if what we're plugging in is less than 0. And g of x actually follows a different function, or a different pattern, when x is 0 or greater than 0. So let's take a look at these three examples here. We have to first realize what we're plugging in. So in our first one, g of 9, 9 is our input. Where does 9 fit in? Does it fit in up here? No. Does it fit in here? Yes. 9 is greater than or equal to 0. That means we're following this bottom rule. So we're going to do the same thing as before. We're just going to plug in 9 everywhere there's an x to this rule, the -1/3 times x squared. So we'll plug in 9. And we first square. And then 1/3 of 81 is 27, so our answer is -27. So basically a piecewise is the exact same thing. You just have to realize which rule you're following depending on the number that you're inputting into your function. All right, for this next one, g of 0, we're inputting a 0. That means we are again following the bottom rule because 0 is greater than or equal to 0. So we're going to plug in 0 to this bottom rule. Negative 1/3 times 0 squared is 0. For the last one, negative 3, we're actually going to be following the top rule because negative 3, our input there, is less than 0. So we're going to follow this top rule, 2 times x, or 2 times negative 3. And we will get negative 6. So piecewise functions look a little bit funkier, but they are the exact same idea. You just have to make sure you're following the correct rule based on the number that you are plugging into your function.